This video is brought to you by Academy of Higher Learning. Hello and welcome to today's video. In this video I'll be going over curve sketching. Now that we are able to find the derivative of any function, we can also draw the graph of these following functions, any functions. So basically we know how to find, if we're given f of x, we can find the derivative, which is f prime of x. F prime of x can tell us that intervals of increasing and decreasing, also critical points, which can be maximum and mins. The other derivative, f double prime of x, tells us concavity. But in this video I'll be only going over f prime of x. So intervals of increasing and decreasing and critical points, and then I'll just do one example. So intervals of increasing and decreasing. So if you recall, the derivative is the rate of change of a function. Therefore, if the derivative f prime of x is positive, therefore that means that the function f of x is increasing. Whereas if the derivative is negative, the function is decreasing. And you can see that in this example, a small example here. If you have f of x equals x squared, anything left of the zero, it's decreasing. Whereas anything right of the zero, it's increasing. And if we find the derivative, f prime of x equals 2x, anything left of the zero is negative. Whereas anything right of the zero, it's positive. So basically, once again, if the derivative is positive, that means the function is increasing. If the derivative is negative, that means the function is decreasing. So next is critical points. Critical points are any points where the derivative is either equal to 0 or the derivative f prime of x is undefined. So I'm just going to go over the last example. So if you have f of x equals x squared, the derivative is f prime of x, which is 2x, and therefore the critical point is 2x. You put 2x to 0 and x equals 0. Therefore the critical point is at x equals 0. And this can also tell us the max and mins, because as you can see that every time in this example, like if we have f of x equals sin x and f prime of x equals cos x, every time f prime of x equals cos x equals 0, we can see that there is either a local max or a local min. So if it's going from positive to negative, it's a local max. And whereas if it's going from negative to positive, it's a local min. And that's not always the case, because if you have a rational function that has an asymptote, it's not always going to be a local max or min. It can also be neither of those. So yeah, so keep that in mind. So that's pretty much basically it about the first derivative. Here's an example: f of x equals x squared plus 2x plus 1 all over x minus 1. So in this example, you're supposed to find the intervals of increasing and decreasing, critical points, max and mins. So let's start. The derivative of this function will be f prime of x. You should be able to find it. So 2x plus 2 x minus 1 minus 1 x squared plus 2x plus 1. Sorry about that. Didn't have that much space. X minus 1 squared. Therefore, if we expand this and collect like terms, we'll get 2x squared minus 2x plus 2x minus 2. So these cancel out, and we'll get minus x squared minus 2x minus 1 all over x minus 1 squared. So collect like terms, that will be 2 minus 1, that will be just x squared minus 2x minus 3 x minus 1 squared, and just factor it. So it'll be, when we put it to 0, it'll be easy to solve. So if you factor it, we'll get x minus 3 x plus 1, and the bottom will be x minus 1 squared. So this is the derivative here. Now to find the intervals of increasing and before I find the intervals of increasing, decreasing, I'll just find the critical points. So f prime, I'm just going to write it here again, equals x minus 3, x plus 1, all over x minus 1 squared. If it's put to 0, that means x minus 3, okay, wait, x plus 1, x minus 1 squared, and x will equal 3 or negative 1, and x is the function f prime of x is undefined when x equals 1. Therefore we know the critical points, which are 3, minus 1, and 1. So next we just draw a chart. That's what I like to do. So it'll be negative 1, just draw like a number line, negative 1, 1, 3. And I'll just change the color a bit now. So anything left, remember, so now anything left, just sub a number in, value in to the function. If you put like say negative 10, this will be negative, this will be negative, and this will be positive. So negative, negative, that will be positive, and this will be positive, so it's positive here. Whereas if you put any value in between one, so let's just put 0 in, this will be negative, this will be positive, and this will be positive. Therefore negative and positive, that equals negative, and positive, therefore it's negative overall. And so it's, and again same thing here. Say if I put like x equals 2 here, negative, positive, 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 so it's negative. And again if I put like 10 here, it'll be positive. So therefore it's increasing here in this interval, decreasing, decreasing, increasing. Therefore next we can find the max and mins. Remember, this is undefined, so there won't be a max or min, it'll just be an asymptote. Here we have, it's going from positive to negative, therefore it's a local max. And here it's going for negative to positive, and it's a min. And sorry, this might not be a local max, it can be also an absolute max. So if you can draw this function, and it'll be something, well, it's going to take a long, I'm just going to do a quick curve sketch on this page, and it'll be something like this. So it's, and here will be a, so x equals 3, this will be a local min, and something will be like that, and here it will be like a max. So this is kind of a bad drawing, but yeah, as for other examples, you can pretty much do any example you want. There are like infinite number of examples, and just write a function, find what I did, local max and mins, even draw the function itself, I mean the graph, and you can test it by just going on Google, writing the function, and it'll show you the